All right, so now we're going to talk about scientific notation. All right, the thing with scientific notation is we have a way of setting up numbers. All right, and so I'm going to use boxes so we don't get confused with variables. I'm going to use boxes for now to stand for numbers. And we can put any number we want in those boxes. So in scientific notation, we have one digit, some number, a decimal point. Sometimes we have a lot of numbers behind it, sometimes we have a few. But the key with scientific notation is you have one digit here, followed by a decimal, times 10 to some number. This number can be positive or negative, as can this number. So let's give an example. So we can have 2.58 times 10 to the third. That is in scientific notation. We can have negative 3.19 times 10 to the 5. That's scientific notation. We can have 1.3568 times 10 to the negative 13. That is scientific notation, because the key for scientific notation is we have one digit followed by a decimal. We have other numbers behind it sometimes we don't, times 10 to some number. Okay, so that's scientific notation. We can even have this, 3 times 10 to the 4. Even though there's no decimal there, whenever we have a whole number, there is a decimal that's invisible. We usually don't write 3 times 10 to the 4. We usually write it as 3.0 times 10 to the 4. But 3 times 10 to the 4 is still considered scientific notation because we know that that decimal point is there. It's invisible. Okay? So this is scientific notation. All right, now let's talk about the other side, which is just standard notation. Standard notation is when we get rid of the decimal. And the way we get rid of the decimal is by moving it. So I'm going to show you two different operations. One is going from scientific notation to standard notation, and the other is going from a number that is also has an exponent or a decimal, and then we're going to move that into scientific notation. Okay, everybody understand so far? All right. So let's go from scientific notation to standard notation. So if I gave you a number, 2.51 times 10 to the third, this is in scientific notation. If I said put that number in standard notation, what we have to do is we have to get rid of the 10 to the power, to the exponent, okay? And how we do that is we just move the decimal. If this one is positive, we move the decimal to the right however many times this number tells us, okay? So we would do 1, 2, 3. So this number is now this. So if this number is positive, so if the exponent, and this is called an exponent or a power, if the exponent is positive, we move the decimal to the right. And that's for standard notation. Okay. Likewise, if you had a number that was, let's say, 5, 6, 4, 9, that is if this number is in standard notation, which means it's just written in a regular way, what do we say about the decimal if we don't write on it? It's invisible, it's right here, right? So what we do is we have to move this decimal behind that first digit, because remember in scientific notation, the decimal is always behind the first digit. So we have to move that. We move it 1, 2, 3, 4. And because we moved it 4 places, we add this in, times 10 to the 4, because we moved it in 4 places, okay? So that's going from standard notation to scientific notation, okay? And notice, to go from scientific to standard, we moved it to the right. To go from standard to scientific, we move it back to the left, Okay, from scientific to standard, we move to the right. Okay, is everybody with me? All right, now, let's look at one more case. What happens if we have a decimal already? If I had 83.21. I still move it this way, right? And since I only moved it by 1, it's going to be 10 to the 1. Okay? So the goal is to get into scientific notation is to put the decimal behind that first digit. Okay? Now sometimes we have a number, different number. Sometimes we have a number that already has a power. So let's say we have 78.3.2 times 10 to the, 4. Okay? We still have to get this all the way over here. So we have to move it twice. Since this is already 4, we just have to add 2 more to it. Because it was already 4, we moved it 2 more, so we had to add 2. If there was nothing here, we only created it with 1. But because it was already a 4 here, and we moved it 2 more, then we had to add 2 more, and that made it 10 to the 6. So this is getting from standard notation or another, just a general writing of a number into scientific notation. Okay? Any questions on that? Nope. All right. Let's look at one more. What if I had something like this? 8, 3, 6 times 10 to the minus 4. 83.6. Okay? I still have to move this way 1 time, right? And I still have to add 1 to this. Remember, on the number line, if we're adding, we're going this way. So if I'm here at -4, right, and I want to go over 1, I'm going to end up at -3 because I'm adding 1. I'm coming back this way. Okay, so with the number line, we always go back this way. Okay, so we have to add this, and this will become. That make sense?
Yeah.
All right, so everybody's clear on this part. Any questions? All right, so now let's talk about dealing with numbers that are smaller. Okay, same concept. So let us say I had to do this. So now we talked about moving numbers this way. Okay, so let's look at some number that's in scientific notation, 4.28 times 10 to the minus 3. Okay? So to move this in the standard notation, we can't move the decimal this way. We want to get rid of this, right? So if we want to get rid of that, we have to move the decimal going back this way, to the left. Okay, does that make sense? So I'm going to go, to get rid of this one, I'm going to move it to the left. 1, 2, 3. So I have to add 2 zeros. Okay? Oops. Right? Because this is a negative, we have to move the decimal the opposite direction. Remember, the other one was positive, we moved it this way. When it's negative, we have to move the decimal the other direction. Okay? So if you're given this in scientific notation with a negative exponent, you have to move the decimal the other way, however many times this is. So if this is a 3, you move it 3 times. If this is an 8, you move it 8 times. So it doesn't matter what the number is, you want to move it that way. All right? Any questions on that? And it works the same way. So if I had 0.389 times 10 to the 4, right? And I wanted to put that into scientific notation, I would move it this way, right? And then what would happen to my decimal? My power, what would happen to it?
Go one.
Okay, we'll go up. Well, let's see. When we moved it, well, before, let's skip that for now. Let me go back a step. Let's go back a step, because I didn't cover that part yet. So let's say I had 0.0486, all right? And I want to move this decimal, I'm gonna move him 1, 2. That'll give us 4.86 times 10 to the negative 2, because I moved it this way. Does that make sense? Before, we were moving it the other way, and we were using a positive value. Because we're moving it this way to create scientific notation, we use a negative value. So if I had 0.00356, I move it 1, 2, 3.56 times 10 to the how many places did I move it?
4.
3. Is that going to be a positive 3 or a negative 3?
Negative 3.
Negative 3, because I moved this way. Okay? Is everybody with me? Okay. So it gets confusing because when we're creating scientific notation, we change the number one way, but when we're going from scientific notation to standard notation, we move the number the other way. So it gets a little confusing. Any questions? Okay.